Moving on to the graph sketching part of the A-level syllabus, and first of all we're going to look at the modulus function, and then we can take a completely different example and run through that to go through some of the techniques we can use to draw graphs. So the modulus function, if we've got y is equal to mod of x, right, these two lines are the sign for the modulus function, and essentially if x is less than 0, then mod x will just be x but positive. Okay, so that's all it does. It just changes the sign of what's inside it if what's inside it is negative. If it's positive, it just keeps it. If it's positive or 0, it just keeps it as it is. So how would we draw this graph? Well, in the positive side of it, x, y of mod x is just equal to y of x, or y equals x, and that's this straight line here with gradient 1, and when x is negative, well, it's going to take negative values of x and make them positive. So on this side we have to draw y is equal to minus x, which looks like that. So that's it for the modulus function. You can put different things inside here and you can explore by yourself what those graphs would look like. We'll move on to another example. So for this example, y equals x plus 4 multiplied by x minus 3 all over x plus 5. We're going to look at how we can sketch this graph. First thing we're going to look at is x asymptotes. So how do we find this? Well, an asymptote is the point that the graph approaches but never quite reaches, and the first thing to check is the denominator of 0. What value of x makes the denominator 0? Well, it's minus 5, so there's an asymptote at x equals minus 5. Okay, so that's going to help us draw a graph. The next thing we look at is intercept points. So when is y equal to 0? Well, y is equal to 0 when the numerator is equal to 0, so when x is equal to minus 4 or x is equal to 3. So now we have two x-intercepts. To find the y-intercept, we want when x is equal to 0. So x is equal to 0, we substitute in 0 here, and we get y is equal to minus 12 over 5. Okay. Next thing we're going to look at is what happens as x and y approach certain values. So as x tends to infinity, well, this numerator has an x squared term, whereas the denominator's highest term is just an x term. So as x tends to infinity, the numerator gets bigger much faster than the denominator. So y tends to infinity as x tends to negative infinity. Well, now this time the numerator still goes quicker to negative value, but to a large value, but the denominator will be negative and the numerator will be positive because the x squared term takes charge over the x term and the minus 12 obviously in the numerator. But so because the numerator is positive and the denominator is negative, y is negative. So as x tends to negative infinity, y tends to negative infinity. Next thing we're going to look at is what we tend to at the asymptotes. So as x tends to minus 5, but from the negative side, okay, and not really a conventional notation or whatever, but so I'm saying as it comes up from minus 7, minus 6, whatever, so the denominator is getting closer to 0, which means the whole fraction is getting larger and larger and larger, but when x is minus 6, you can see the denominator is negative, so we've got negative fractions, and we're getting bigger and bigger negative fractions. So y tends to negative infinity, and as x approaches minus 5 from the positive direction, well, we have the opposite effect. We're coming from minus 3, minus 4 to minus 5, approaching minus 5, never quite getting there. So we're getting bigger and bigger fractions, but positive fractions, so y tends to infinity. Right, in a second, we're just going to look at a way we can find the stationary points, but not using differentiation like we normally would. So I'll see you in a second. Right, so the method we're going to use to find the stationary points and regions where there is no graph drawn is by substituting y is equal to k, and then using this to find out how many solutions of k there'll be for certain values of x. So substituting in y is equal to k, and then rearranging and collecting like terms gives us the quadratic 1 plus 1 minus k x minus 12 plus 5k is equal to 0. And pretty simple, if you just multiply by the denominator of our original fraction and then subtract k multiplied by x plus 5 from both sides, this is what you get. Okay, so very easy stuff. And then to know how many solutions we have of a quadratic, we know we can consider the discriminant, and the discriminant in this case is 1 minus k all squared, minus 4 times 1 times minus 12 plus 5k, so that's just plus 4 12 plus 5k, and again collecting the terms, we get the quadratic k squared plus 18k plus 49. When you find the solutions for this being equal to 0, and then you plot it, you get a graph that looks something like this, where this is equal to minus 9 minus 4 root 2, and this is equal to minus 9 plus 4 root 2. Okay, and essentially what we want to know in the discriminant is when this is when this quadratic is less than 0, which is in between minus 9 minus 4 root 2 and minus 9 plus 4 root 2, when it has two solutions, which is above the x-axis, so when x is less than minus 9 minus 4 over root 2 and greater than minus 9 plus 4 root 2, and when it has just one solution, which is our stationary points, which is at x is equal to minus 9 minus 4 root 2 and x is equal to minus 9 plus 4 root 2. So now we're going to have a look at drawing our graph. So here's my final sketch for this graph. Not the smoothest sketch in the world, but it's got all the elements. This is minus 5, the asymptote that the graph approaches and never quite touches. Sorry about that. We've got our intercept and our y and x intercepts right. We've got our turning points. We've got a space in between the 2 points that we found using our y equals k technique, where there's no solutions. And if you do type in the graph we're trying to plot on a Desmos or something like that, you'll be able to see that the graph does come out looking something like this, and hopefully you can understand the techniques I showed you so that you can produce this graph by yourself. If you do have any questions about graph sketching or anything else, please be sure to let me know down in the comments. If you did find this video helpful, please be sure to like and subscribe, and I hope to see you in the next one.